All right, superb. Thank you very much for having me. It's great to actually be on GroupBy because a couple of years back I tried and very unsuccessfully, I might add, to get on GroupBy, and well, it didn't work out. So I went back home, I licked my wounds, and now I'm here. And as I usually say, and this is kind of fun because it's the same timing here, I have two observations. One is I am between you and lunch, and the other one is that you're in the only session in the catalog with the name boring in it. And that's the thing. Boring is stable and stable is good. Picture a world where all the databases were configured exactly the same. Everything was proactive and everything was configured for maximum performance. Now, picture your environment and ask yourself a question. On a scale from 1 to 10, how good is your setup? Hmm? So this session actually contains two absolutely horrible pictures. I feel that I need to warn sensitive viewers about these pictures, and I'm going to show you the first one now. This was me back in 1998. This is what was my first job, and I was asked to set up a number of new servers. I didn't have the requisite either knowledge nor experience, but I was told to figure it out. That's kind of a challenge for a 19-year-old whose entire database experience was Access. The web was still some time off, so it was kind of difficult to actually find the relevant information. So the experience, it planted a seed in my mind that's been growing on and off for 20 years. And this session is pretty much the culmination of this work. What defines a best practice? What is the point of a best practice? How do you evaluate best practices? The point is to guarantee consistency, set up proactivity, and maximize performance. You don't want your servers to be entirely unique. That makes it hard for everyone else to manage them. You don't want to look at each and every server you have thinking that it's working as it should. You want to know this, and you don't want any settings that are going to kill performance. So consistency, proactivity, and performance. Those are the three main things that we want to have in this setup. So back then, I was firmly in the technical domain. The only thing that I cared about was tech. And what I did was I started to think about what do you need to set up a database properly? What settings to use, where to place files, and so on and so forth. And that was pretty much the only thing that I thought about back then. So we'll start there. We're going to go through three sets of settings. The first one is the server settings. The second one is the disk settings. And the third one is the SQL Server settings. And let's start with the server settings in a bit. My name is Alexander. I have roughly 20 years in IT, pretty much all of it spent with data, databases, and infrastructure in some way, shape, or form. I work for Atea in Sweden, mainly doing evangelism, training, and architecture, and anything work related to the data platform stack. My absolute favorite toys in the box are SQL Server, Azure, and Power BI. And I go all over the world speaking at conferences. I teach Microsoft courses. I'm a data platform MVP. I co-host a podcast. I actually did a Pluralsight course that was relevant for all of 2 weeks until Microsoft changed parts of Power BI. I make data matter because only data that matters can inspire change. So what about the server? Well, patching kind of goes without saying, and I'm going to hold that thought for a bit, but patching, you need to patch your server. Most people think that, all right, I'll just patch my SQL Server. No, the SQL Server is running on an operating system. So this is a bit of a no-brainer, but I'm going to say it anyways. Patch your servers. What about the antivirus? Well, I'll make it simple for you. Don't use antivirus on a server where you have SQL Server. Simple as that. Why? Well, what does an antivirus system do? It is going to insert itself between you and every operation there is. So if I try to access something from the disk, it's going to go through the antivirus level, so to speak. And that means that you are going to have latency. You're going to incur latency with antivirus. Well, some of you are going to think, I just need to exclude the data files or the database files from the antivirus. It's not quite that simple, because the antivirus system still needs to check, is this file on the exclude list? Yes or no? And yep, we're back to latency. So at the end of the day, try to avoid antivirus if you can. I know. There is something called reality out there. And in some places, you just don't have a choice. But if you have a choice, don't install antivirus. And here's another fun thing for you. If you put in antivirus once, you cannot get it out. You might as well just toss the machine completely and reinstall, because some parts of the antivirus will stay behind even if you have uninstalled it. So you're probably going to see some latency. Now, these are generally not huge, but be aware that they might eat some of your performance. Another one that is pretty fun is hyperthreading, and it depends entirely on what kind of workload you're looking at, what versions of SQL Server you're looking at. But in general, and this is in general, you're not going to see very much performance gain with hyperthreading at all. I think Chris Adkin did a very thorough walkthrough of SQL Server hyperthreading and batch mode back in 2015. In general, hyperthreading can be useful in an environment if the workload is comprised solely of extremely lightweight transactions, which is very, very rare. And under these conditions, maybe you can see up to 30% increase. So my recommendation is generally to stay away from hyperthreading. But again, your mileage may vary, so make sure that you test. Memory. SQL Server has the same opinion of memory as my cats do food, as in, give me all the food, human. And if you find yourself between my cats and their food, well, I'm sure, I hope you wrote your will, because yeah, you're dead. So don't do that. So what's the thing with memory? How much memory can I put into a box? Well, this is slightly dependent on if I am talking to people in the US or people in Europe, because most of the time in Europe, we tend to stay on standard edition. We don't have the money for the expensive edition, which is kind of sad because the expensive edition has some very nifty features. But have you seen the number 2 petabytes? Yep. So 2 petabytes is the maximum amount of memory that SQL Server will do out of the box. And that's generally more than most of my clients have in their servers. But how much memory can you actually put in a SQL Server? Well, let's look at slightly modern versions, 2014 and upwards. On a standard edition, you can put in 128 gigs on the server. Or can you? Now, here's the funny thing. What do you think the edition memory limit actually controls? Well, let's look at what we have in SQL Server, shall we? What we generally think of when we talk about the memory is the buffer cache. This is where all the stuff goes. We pick up stuff from the disk and we toss it in the buffer cache, and then the different sessions can access the data from the buffer cache, right? But there are so many more things happening in SQL Server. We have the procedure cache, the connection context, system level data structures, log caches, and these are only examples. There's so much happening in the memory of SQL Server. So what does max server memory, the maximum edition memories in the server actually control? It only controls this. So what does this mean? Well, let's look at an example. The maximum amount of memory we can have in a standard edition is 128 gigs, but that is only 128 gig limitation on the buffer cache. So if I put in 166 gigs of RAM in the machine, SQL Server will not only use the 128 gigs, it will actually use much more than 128 gigs. Because again, the buffer cache is the only thing that is capped at 128 gigs. So in order to actually use the memory most efficiently in your standard edition server, you need to put in more memory. And for God's sakes, always make sure that you reserve memory for the operating system. And the irony is that the more memory you have in the machine in total, the more memory you need to reserve for the operating system. Anyone who's been around the block a few times and remember how much fun it is to take up all the memory on a Windows 2000 machine or a Windows 2003, it will simply go boom and fall over and die. That is generally frowned upon in a production system. Moving on, power.
Can I just interject? We had a quick question in the Slack channel. Does the memory limit make a difference if the box SQL Server is on a VM instead of a physical box?
That is a very good question. And no, it does not. It's just for it's for the VM. So you can have more than, it's the number, the amount of memory that you allocate to the VM that is the key. All right. Now, power. This makes me angry, as in very angry. What is the default setting for Windows Server in 2019? It is balanced. Who on earth wants the balanced power setting on a server? Please. But that's what we have to work with. So the very first thing you should do is to turn your server to maximum performance and not on the balanced setting. So this can actually hurt you pretty seriously. So make sure you set your power settings to maximum performance. Instances. How many instances should you have on a server? Well, let's make it simple. Again, the only reason to have more than one instance is to save on licensing. That's it. Because as soon as you start piling on instances, you are starting to use up memory and resources of that machine. So if you need more instances, you're also going to find yourself in the unenviable position of having a named instance. And a named instance can be a bit of a pain in the posterior when it comes to accessing it. But there's a funny trick. Give your machine more than one IP, and then you allocate one IP per instance. Why? Again, because one instance, one IP, and per IP you have ports. And if you have your instance running on its own IP, then it can all run on 1433. And here's the funny thing. If your instance is running on 1433, that means that you don't need to care about the name. Ta-da! So this also
is genius.
It is genius. And it's so simple. The first time I saw this, I just went, whoa. So
how come no one told me this? I've been working with SQL Server for like how long? It's amazing.
There's always some interesting tidbits that you pick up along the way. So just to clarify again, make sure that your server has its own IP and then it's all on 1433. So if you need to move your instance or database for whatever reason, it doesn't matter. It can move to another server, but you just keep your IP. And while we're at the concept of instances, my recommendation, use DNS and give every database its own CNAME. This makes it so easy to move databases between servers or database hotels or whatever. So just a small extra tidbit. GMSA, globally managed service accounts, as in I am lazy and I don't want to hack away with my service accounts. So don't. Let Windows sort this for you. It's going to create a super secure password, and it's going to update this periodically. You don't need to know. You don't need to care. Just do it. The second part is disks. And disks are a bit contentious, and this is also kind of fun. Back in the day, we had the issue of alignment. I vividly remember trying to create Windows Server 2003 on VMware and having the alignment out of whack, and it was absolutely horrible. These days, alignment on virtual machines are generally not an issue. And I say generally, but most of the time it's not. But we always get into discussion about stripe size. I recently did this session in Holland, and I asked my audience, so what is the block size that SQL Server uses? And people said 64K. Still, hold that thought for a bit. Why does this matter? Well, it matters because of this. This is the default setting in NTFS, the Windows NT file system. It defaults to 4K allocation size. So all the bits and pieces that we actually store on the disk, they're done in 4K. Now, SQL Server can use, let's just go with the preconception that it uses 64K, right? So that means that we're going to need to use 16 operations on the disk to just handle one block in SQL Server. But it gets worse. Look at this. We're actually going to do IO block sizes between 512 bytes up to 8 megs. 8 megabyte. That's bigger than 64K, and I suck at math. So what you need to do is definitely format your drives to 64K. You're going to see performance gains. The only time that I did not see a performance gain was running on NetApp, because NetApp has its waffle file system underneath, so we could not detect any real change in actual performance. But otherwise, you are going to see a net gain in IO performance by formatting your drives to 64K. Unfortunately, before you run out and try to do this, just be aware that you need to do this when you format the drives. So if you have your data there, yeah, it kind of sucks because you need to move it, reformat, and move it back. Whoa, that was quick. Disk layout. There are many ways of laying out your drives. This is what I do. And the main important things here are the C, that's the operating system. Don't ever put SQL Server on C. I would actually go as far to say don't put anything on C. Why? Well, filling up the system partition on a Windows machine is not fun. And again, if you've been at this for a while and you tried to do that on NT4, well, getting an NT4 machine to actually run after you fill up the C drive was an experience in itself. And these days it's better, but it's not fun at all when you actually fill it up so it can't boot. So put SQL Server on its own drive. Several reasons for this. If you have logs that suddenly explode for one reason or other, make sure that you fill up the D drive and not the C drive or the other data drives. And then you can look at getting data and logs and backups and stuff at their own stuff. And there's another interesting preconception that says that data is serial IO and logs are random IO. No, quite the opposite, the other way around. Data are random and logs are serial. Now, the funny thing is that this is not true either. Well, it is true if you have one log file. And most of the time, you're going to have more than one log file. And as soon as you have more than one log file from more than one database, suddenly your serial IO is going to turn into random IO. So you don't gain very much from separating the data from the logs when it comes to access patterns on the drives. But you do get different queue handling in Windows. And, well, again, you don't want to fill up a drive at the same time. You don't want to lose one drive that contains both logs and data. Then it comes to TempToBe. TempToBe is the public toilet of SQL Server, and all kinds of shit is going to end up in TempToBe. And if you only had one SSD, back in the old days, you would just have one SSD and a lot of spinning drives. Where would you put the SSD? Most people would say the log. No, put it underneath the TempToBe, because everything is going to happen in TempToBe. So make sure that TempToBe is the fastest storage you have, because otherwise you're going to be suffering again from performance issues.
And this is great advice for cloud virtual machines where the SSD is typically local and temporary.
Absolutely. That's a very good point. And the next thing, IFI, the instant file instantiation. Whenever you're extending a data file or creating a data file in SQL Server is going to go, I want a file. It's going to toss this to Windows. Windows is going to go, sure, I'll give you a file. And it's going to start writing zeros. And if you're doing a 20 gig file, it's going to be writing zeros for a while. Now, of course, the faster storage you have, the less impact you're going to have. But at the end of the day, you're going to have some kind of impact. And when you're extending a data file because you've found that it needs extending, it's full, well, then you have a complete blocking operation. Nothing is going to happen in SQL Server until the time that this file has been extended. So what you can do is turn on the instant file instantiation, IFI. There are a couple of ways of doing this depending on which version you're on. The left here is the older versions and the right is 2016 and upwards, but they do the same thing, grant perform volume maintenance task. And this means that SQL Server is just going to go to Windows, give me a file. Windows is going to say, sure, here, go ahead. And it's going to give you back the file start and finish, but it's not going to zero out all the blocks. This has a kind of a security implication. And most people say, well, if someone can actually read the data, the raw data file using dbcc commands, well, then you have issues. Well, look at it this way. If you're doing some super secret squirrel stuff, highly classified or that kind of stuff, and you need separation of duties between the DBA and the whoever used the disk beforehand, then you do not want to turn on IFI, because IFI enables you to read the state of the drive or the disk, where the files now reside. What you can read what you actually had on the drive before, and that might be a security issue. Otherwise, turn this on because it is going to save you so much time. Unfortunately, this does not apply to log. It is only applies to the data files. And we come now to the SQL Server settings. Oh yeah, this is going to be fun. First of all, patching. Everybody should be patching. Unfortunately, this is not the case. So let's start with this, SQLServerUpdates.com. It's run by Brad Ozar, and it gives you all the updates, all the latest updates, the URLs for downloading it, and so on and so forth. All the stuff in one place. How often do you need to patch your SQL Server? It depends again on which version you're on. Up until 2016, or up until and including 2016, you should only patch with the service packs. You do not touch the CUs, the cumulative updates, unless you had a specific issue. 2017 and upwards, this changes, and there's still a lot of people who don't know this. You need to patch with all the CUs as they come out. Otherwise, you are not in a supported configuration. So this means that you're going to be patching SQL Server a lot more 2017 and upwards than you did previously. And in Azure SQL Server, it actually patches every night. And what's even more funny is a lot of the patches that they do are injected into the running SQL kernel. There's actually a white paper on this, which is very technical and very fun, how they do patching on the running kernel. So that's kind of cool. We don't have this in the on-prem version yet. It is not in 2019 either, but maybe in the version after 2019. I don't know that, but there are some nifty features coming that way. And I also told you that there are two horrible pictures. You've already seen one, and you've just kind of sprung back from that. It's time for the second horrible picture. There we go. And I think I'm going to have a talk with my keyboard in a bit, because not everything is working the way it should here. There it is. So we have a few things to go through. Let's start with the trace flags. Trace flags, depending on who you ask, is either something you should never touch with a 10-foot pole or something you should always use. Well, there are a few trace flags that you definitely want to look into using. 1117, 1118, they work with TempToBe and the using files in TempToBe. 2371, 2562, 2549, and 4199. I'm going to put all this in the slide deck, but just so you heard them. Now, people are going to scream, whoa, 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 you don't need to use these because I'm on 2016, I'm on 2017, and I'm on 2019. Well, good for you, because a lot of the stuff is already built in to these versions. But if you run a database with a compatibility level that is lower than the version you're running on, say, for instance, if you're running SQL Server 2017, which is 14, I think, if you have a 2014 database, well, you still need to use the trace flags, because otherwise this is not going to happen on that database. Then we have the log pages in memory. This actually spurred one of the biggest controversies in the SQL Server community a couple of years back. And Jonathan Kihayas has a great blog post with both sides of the argument and a lot of interesting information. What it is means that if I lock SQL Server pages in memory, there is nothing on this earth that can take the memory away from SQL Server. My first thought is, that's awesome, because that means nobody can take my memory, because I need all the memory, right? Unfortunately, this also applies to Windows. And Windows generally don't like it when it comes under memory pressure, and for some reason cannot get memory back. So if you have a memory-starved server, or if you're running on a virtual machine with a lot of other VMs on the same server, this might be kind of dangerous, because you're basically disabling the balloon driver in VMware, for instance. So it might be a good thing, it might be a bad thing. Again, test it out, and your mileage may vary. Then we have DBA tools. A couple of years back, I was introduced to Chrissy Lemire and Rob Sewell, that are the main people behind DBA tools. Or actually, Chrissy was the one that created DBA tools. And I am absolutely horrible at PowerShell, but the things you can do with DBA tools and PowerShell, wow, it completely rewrote the book on how I take care of a lot of servers. So how do I get DBA tools? It's easy. Go to dbatools.io and then just go for download, and either you download it and install it that way, or use the PowerShell marketplace, so to speak. And there are so many commands. And this screenshot is already old, because the Datagrillen earlier this year, they released version 1.0. And there's always new commandlets and scriptlets coming out, and there are so many amazing things that you can do with PowerShell that are generally so hard to do manually. SPNs, for instance, with SQL Server, they can be a bit of a horror to take care of. Easy peasy, no issues at all with PowerShell. So just get this in on every server you own, and everybody else's services too. Do it. I'm not going to pay for that. SQL Mail. Why on earth would a SQL server need to send mail? Well, how else could it tell you that it is not feeling okay? There are actually structures inside of SQL Server designed to alert you when something is off. And I'm going to get back to those in a bit. But unless SQL Mail is configured, it is difficult for SQL Server to actually get your attention. So make sure that you set up SQL Mail and test it, because I've set it up a few times and not tested it. And oh yeah, I could not send mail with that machine. And just make sure that your server can actually send you email. And also when you set this up, configure it so the name of the server is correct. Otherwise, it's going to be interesting to try to troubleshoot whatever issue you actually get a mail from. Then it comes to memory. What about memory? Well, again, use more memory than you think you need. I still find it hilarious that I can come out to a client and find that their servers in 2019 are still running on a machine with less RAM than my laptop. That is just wrong. And no, I don't have a huge laptop. My laptop has 16 gigs. Duh. So, I mean, it's easy. I am going to be much more expensive than my client buying 16 or 32 or 64 gigs more RAM. It's a no-brainer. Just do it. Make sure you have enough memory. SQL Server likes memory. Give it memory. Just put more memory in, please.
There are so many horror stories about under-provisions or under-memorified SQL servers.
Under-memorified. You heard that word
yeah,
here
I
the
kind of
first
just
time.
made it up.
Well, it
I've had
works.
clients set up a data warehouse server with 6 gigs of memory, and that was VM memory, not SQL Server memory. Yeah, that was a discussion.
I have a headache. Horrible. Then we have the DAC, the dedicated administrative connection. Again, surprisingly few people know about this, but SQL Server is the only piece of Windows software that does not rely on the process scheduler of Windows. It has its own process schedule known as SQL OS. And again, there's a lot of technical stuff written on this, but this also means that if SQL Server hangs, you're probably not going to be able to get into it unless you have the DAC turned on. The DAC means reserve one process for an administrator to connect to. And it might mean the difference between getting into the server and being able to kill whatever noisy neighbor process is doing its thing at the moment and not having to reboot the machine. So turn it on. It only costs one process, and that's dead cheap. It is perfect for being able to sleep slightly better at night. I recommend it. Then we have max stop and cost threshold. So max stop means max degrees of parallelism. And cost threshold means how quickly is SQL Server going to consider parallelizing a plan. Now, this comes with a few very funky basic settings. These are the defaults. So let's unpack those for a bit. Max stop, again, how many CPUs are we going to rope in to do whatever query we want to do, right? So we have, let's say for instance, we have eight CPUs in a box. With max stop 0, that means that we're just going to use one CPU. No. It means they're going to use all of the CPUs. How is this an issue? Well, let me give you an example. Let's say, for instance, I buy a huge bowl of Skittles. And I mean, Skittles are candy with a lot of different colors. And I want to sort this. So I want to have green, I want to have yellow, blue, and red. Either I can just take my huge bowl and start sorting and be quiet for 15 minutes, which is going to make this session even more boring, actually. Or I can divide this into smaller piles and give them to all the people in the audience. And then you can sort them. And when you've sorted them, you give them back to me and I'll tally the whole thing. Unfortunately, at least one of you is going to be doing something else, like looking at Twitter or Facebook or cat pictures. I don't know, but you're not doing any sorting. You're not sorting my skittles. And that means that everybody else that did their job and I did my job, we get to wait, because it's not until you've sorted that I can take the whole thing and put it together. That's known as parallelism skew. And this is also what generally shows up as CX packet issues, parallelism issues in wait stats. And this gets actually compounded by the issue of the cost threshold for parallelism. One of the other sessions, I have a picture of a Dell Optiplex 200 megahertz desktop. And that was the machine of Gene Amdahl, who used to work for Microsoft and wrote most of the stuff inside of the optimizer cost thing. And a cost threshold, or actually I should say a cost of 5 on that machine, meant that it took 5 seconds to run. Now, I don't know about you, but I kind of think that a few things have happened with servers since then, like a lot. So 5 doesn't mean 5 seconds anymore. 5 is just an arbitrary number. And what actually gets worse, I cannot compare a 5 on this, on my machine to a 5 on your machine, because unless they're absolutely identical, the numbers don't mean anything. I can compare two queries on the same box, like one costs 5 and one costs 19. The 19 is probably going to be slower. So these numbers are just absolutely bonkers to start with. Never, ever leave these at defaults. I would recommend, I think that's the 5th time it did that. I would recommend to go 1, 2, or maybe 4 for the max degrees of parallelism. This is depending on how many CPUs do you have. Generally, you don't want to set it to 1, because that means if you find yourself doing a huge query that could actually benefit from being divided into several, you're not going to be able to do that, because 1 means you just use 1 CPU. 2, 4, well, it means use 2 or 4 or higher numbers of CPUs to do one single query. But again, don't set this to the same number as your CPUs, right? And when it comes to cost threshold, what I recommend is go to 50 as a starting point. Keyword being starting point. There is a piece of SQL Server lore that says roughly 50% of the queries in the query cache should go in parallel. Use that as a starting point. So go for 50 and then take a look in your query cache. How many of my plans are actually going in parallel? All these can be changed on the fly, but don't do that. Because, and this is stated in the documentation, but it's kind of stated in pretty small letters. It says that if you change MacDop or cost threshold, it is going to clear out your cache. So it has the same effect as restarting your server. And that is, again, generally frowned upon on a production environment. Just saying. We keep going. Optimizer Adhoc. Optimizer Adhoc means that the first time SQL Server sees a query, it will not store the whole query plan. It will only store a stub. And this is because if you have a lot of ad hoc queries, i.e. queries you just see once, you don't want to store all these plans that you're not going to reuse anyways and basically bloat your cache. So turning on Optimizer Adhoc puts the pressure on the plan cache much lower, and it means that you get to use your memory for more optimum, in a more optimum way. Now, a word of warning though, Dynamics AX, it specifically says in the documentation, do not turn on Optimizer Adhoc. So make sure that you know before you start fiddling with this, if your environment is supported for it. So just check it. Oh, and another fun thing with MaxStop and cost threshold, there is one piece of software that requires you to set MaxStop to 1. Yeah, it's the software we all love to hate, SharePoint. If you feel, for instance, that your sleep patterns are much too good, that you need to have your sleep disrupted, take a look at what SQL Server creates, or take a look at what SharePoint creates underneath in terms of SQL queries. They are absolutely horrible.
For those who have SharePoint databases on their servers and have set MaxStop for the entire server, if you have, correct me if I'm wrong, 2016 or newer, I think you can set the MaxStop per database. So
That's
now you can set that
point.
one SharePoint database to MaxStop 1.
It's known as scoped database settings, and it actually is both MaxStop and cost threshold. So those should definitely be set per database. Now, I am not entirely sure that SharePoint actually looks at the scoped database settings yet, but it should. I'm just not entirely sure. So backup compression. Of course, we should compress all our backups. Yes. And then comes your SON and storage people, and they are going to go bananas when you start compressing stuff. Because if I compress my database backups, they can't compress it when they try to store it on their systems. That means that their numbers are going to be bad, my numbers are going to be good. I'm pretty pragmatic. I'm the database admin. It's my posterior on the line when something goes pear-shaped. I need to know that I can get my database back as quick as possible. And that means reading from a compressed backup, because backing up is not that, I was about to say the backing up is not that important. It's the restore that is important. Now, they kind of go hand in hand, but you get what I'm saying. So I would say always use backup compression for obvious reasons. But again, you're going to find yourself having a bit of a conversation with your SON people. Sucks to be them, in my opinion. TempToBe. Well, we've been at it before. TempToBe is the public toilet of the SQL Server. Everything happens in TempToBe, and by default, TempToBe has exactly one data file. Inside this data file, there are a couple of structures, the global allocation map, the shared global allocation map, and the page free space map that keeps track of what's happening in this data file. Now, this is not entirely unlike a festival, because there's going to be a lot of people inside of these files at any given time. And this means that you are going to find yourself in a contention situation. So what you want to do is take all these bits and pieces and make sure that you have more than one. And to make things simple, use one data file per core. It's slightly lies to children, but go for that and you're good. There's no issue basically of having with having more than like 8 data files. So just go ahead and do this. Now, you need to turn on trace flag 1117 and 1118, because if you don't do 1117, you might find yourself with one data file being huge and all the other data files not being used at all. 1117 means that allocate equally and make sure that all your files should have the same size. Never have different sizes in any situation at all. And while we're at files, you don't want to have a percentage as a setting when it comes to data file growth, ever. If you set percentages on data file growths, I will fine you. You don't want that. Speaking of data files, by the way, there are so many fun things you can do here. So we don't want to have percentages, right? And look at the default size increases for log files. I think it's like 1 or 2 megabytes. What? 1 megabyte? I used to have floppies and the smaller, how How many 3.5-inch floppies? That's 1.44 megabytes. Sure, back then it made sense with 1 megabyte, but these days, come on, bump that number up, because the larger your log file, the difference it's going to have on what's known as the virtual log files cannot be overstated. So in general, when you grow a log file, you're going to get a new virtual log file. And the number of virtual log files you had in there from the beginning depends on the size of the data of the log file, right? So if you make a log file big from the get-go, you're not going to have like a gazillion VLFs. Why does this matter? It matters when you do a restore. I have seen a restore of a database that was less than 2 gigs take 20 minutes because of the fact that the log had like a few thousand virtual log files. The recommended number is varying, but somewhere around 40 to 80, depending on who you're asking, is a reasonable number of VLFs. And if you want to change that, you're going to need to work a bit, but make sure that you don't have a gazillion VLFs. And the easiest way of doing that is to make sure that your log files does not grow with just a teeny tiny amount. The query store came out in 2016, or actually there are bits and pieces inside of 2014 already, but you cannot use them unless you're on 2016. And the query store is the holy grail of performance tuning. Oracle has had this for many, many, many years, and it was a complete surprise to me that this was not part of SQL Server, but we got it in 2016. So what it does is it's actually saving the cached plans to enable you to go back and see, okay, this query performed great yesterday and now it sucks. How do I get back to whatever it did yesterday, and how can I see what the difference is? So I would recommend you to turn on the query store, but be aware that this incurs a slight performance pain, just a slight. I think it's actually worth it, but make also sure that it does not grow beyond control. There is some housekeeping involved with running the query store, but it is well worth it. Now, if you're running 2014 or earlier, it's kind of sad to see the query store, but there is a solution for you. William Durkin came up with what is known as the Open Query Store. And this is a set of scripts that gives you kind of the same functionality. It is absolutely amazing. It can be a bit fiddly to get it to run, but when it does, you have almost the same functionality, and you have so much more insight into your SQL Server than you did just 20 minutes earlier. So go get this one. It's not expensive at all, as in it's completely free. I said about the operators and the alerts earlier. So SQL Server will happily send you email, and there is something called alerts inside of SQL Server, and the alerts gets triggered by different things. And you can set a alert on a number of severity issues, and look at Brent Ozar's blog, because he has a lot of stuff here. And what you want to do is create alerts for a lot of these errors. And whenever something happens in the log, in the SQL Server log, the alert's going to fire and send you an information to an operator. And an operator, in this case, it's just an email address. So this means that whenever you find yourself in a tricky situation with, for instance, a deadlock or a corruption, you're going to get an email immediately. And that is so much more fun than coming back from vacation 6 weeks later and realizing, oh, I have some corruption that I didn't know about. It can be the difference between a quick fix and a horrible fix. So make sure that you turn these on and actually send the emails to somewhere that gets monitored. So many times I've set this up at clients. Clients go, well, I'm going to get a lot of emails, so I'm just going to ignore these. And the funny thing is that they just started ignoring real issues. So take care of that. And this also brings us to the agent config. And the agent needs to know about the SQL mail. Out of the box, the agent does not talk to SQL mail at all. So you need to set up inside the agent that it is allowed to use SQL mail, which profile to use, and so on and so forth. So as it is the agent that does the alerts and the operators, the agent needs to be able to do this. And also make sure that you know where the agent log is, because again, when the shit hits the fan, it is kind of too late to start Googling where to find your log files. Maintenance. Who does maintenance these days? You don't need to do maintenance. Maintenance is boring. Sure, it's boring, but it can be made so much easier. There is a Swedish guy who ironically is working for an investment bank in Denmark, Ola Hallengren. He wrote the SQL Server maintenance solution, which has become the de facto standard for maintenance. It does CheckDB, it does index rebuilds, it does backups, all these things automatically for you. I just put this on all my clients' servers because if it's there and if it's scheduled, it runs as an agent job, I know that it's going to work. It's going to be perfect. And a quick aside, do you actually need to do reindexing on SSDs? Well, most of the time, no. You don't no longer need to do DBCC reindex every night. Only for specific situations where you load a lot of data, for instance, or maybe once a month. But look it up. Just be aware that you might not, or probably don't, want to do every night. So how do you get this? Well, there are a few ways. Excuse me. One is to just go to the SQL Server maintenance solution and download the whole script, or you can use install DBA maintenance solution in DBA tools. Ta-da! It's so easy. It is amazing. So what more do we need to think about? These are the technical aspects of SQL Server. Now, I kind of grew up, even though my wife not necessarily agrees, and I started thinking about the softer parts of being a DBA. And this is where you kind of start to move from a junior DBA to more senior roles, because suddenly you realize that there are others that need to be able to do what you do. There are others that need to be able to take care of something while you're not there, for instance. So the absolutely first step is to document. And everybody loves documenting. No, I can see you all shaking your heads. But sucks to be you. You need to document. And what is the definition of a good documentation? Well, if I can take the documentation from somebody else and immediately know what I need to do, then we're on the right track. If I can give my documentation to anyone with little or no DBA training, and they can actually do the day-to-day work, now we're talking. Because when the shit hits the fan and I'm not there, people are going to start running around, throwing things in the air, and let's just face it, not be their absolute best. So make sure that the documentation is good enough. Add some hours to it, and it's going to be worth it. The next part is baselining. Why would you want to baseline anything? Well, if someone was to come to me and said, my query is slow, my immediate response is going to be, compared to what? Well, it was faster yesterday. Ah, now we're talking. So this is where I whip out my baseline, and I can see that the query used to run for 2 seconds, but now it runs for 16 seconds. Something is off. If I did not have the baseline, and it was just my query is slow. How do I know compared to what? This is going to impact how I approach things so deeply. So do your baselines. You're going to love me for it. Then automate the heck out of everything. Just do it. You don't want to do boring. And again, use stuff like DBA tools. It is amazing for automation, because if you automate it, A, you don't need to do it, and B, it gets done consistently every time. And it's probably going to be faster too. This frees up time for you to do more interesting stuff. And I don't necessarily mean surfing for cat pictures, even though that's kind of fun too. And the part that people tend to forget, train your coworkers. And it doesn't matter if it's a DBA or not. Just make sure that someone is there to pick up the slack if you're on a vacation or even in the bathroom. Because make sure that someone can do something when the shit happens. The shit never happens when you're prepared. It always happens just after you open a cold one at the beach somewhere. So make sure you have someone to take up the slack. So in summary, SQL Server is not very well configured out of the box, but following just a few best practices and making consistent changes, this can pretty easily be mitigated. And it is absolutely vital that you take these best practices, which all have a shelf life best before date, by the way, and look at how they impact your environment, because my environment is not the same as your environment. So you need to know exactly what they do and what they cannot do. As I said in the beginning, you're in the only session with the word boring in it, and tech is inherently not boring. In fact, the speed of innovation is downright scary, especially with SQL Server. Having said that, boring is stable, and stable is good for production. And as I said, these best practices come with the best before dates, and you take them, you refine them, and you use them as you see fit. Only you know your environment, and only you know how to make your life a little more boring. My name is Alexander, and I thank you so much for your time.